Hello, everybody. All right, so we are moving on to right triangle trigonometry. So this is what we're going to focus on here. We're going to use right triangles to evaluate. We're going to find function values for the 30, 45, and 60 degrees. We're going to recognize a few fundamental identities and look at co-functions of complements. And then we're going to evaluate trig functions with a calculator and use right triangle trig to solve problems. All right, so here we go. So we have 6 trig functions. Up to this point, this is what you have learned up to this point. You have learned sine, cosine, and tangent. So there's 3 others that you are also going to have to learn, which is cosecant, secant, and cotangent. And basically what these 3 are, they're just reciprocals of the original 3 that you already learned. And you should have and hopefully remember these from geometry. So when you first have seen sine, cosine, and tangent, you actually learned it in geometry probably right after you came back from break starting the first semester. So to refresh your memory, we have right triangle definitions. So looking at this, so this is the ones you should already know at this point. You have sine, cosine, and tangent. And if you remember, there was a specific saying, SOHCAHTOA. And so when you're doing this, these all relate to something. And it's all going to relate to the angle in question. Okay, so when you're looking at these, and we're going to go into these, everything is going to be based off your angle in question. So focusing on an angle in question, your sine is going to be the opposite side over the hypotenuse. Your cosine is the adjacent side, so the side that's actually touching your angle in question and the hypotenuse. And then the tangent is opposite over adjacent. And so if you notice, it's the numerators of the sine and cosine, because tangent is sine over cosine. So since tangent is sine over cosine, that would make sense that its relationship, its ratio, is going to wind up being opposite over adjacent. Which brings us to the 3 new ones. And so if you're looking at the 3 new ones, so it's the same thing. So cosecant, that is the reciprocal of sine. Okay, so let me go back a slide here. So when you're looking at these, oops, didn't mean to do that. So when you're looking at these, you have these pairs that are going together, that they're going to be reciprocals of each other. Sine goes with cosecant. Cosine goes with secant, and tangent goes with cotangent. So each set has one co in it. You can't have 2 co's. So just kind of remember that. Maybe that'll help you trying to remember. So if you have sine, it can't be secant. It either has to be cosecant or cotangent. Well, cotangent, this one should be obvious since it has the actual word tangent in it. It should actually be with tangent. So that's why those 2 go together. So you're left with these 2 that are here, the cosecant and the secant. Well, since each set has to have a co with it, sine goes with cosecant and cosine goes with secant. So that's how they wind up going together. So that means if I'm looking at cosecant, well, cosecant goes with sine. Well, sine is opposite over hypotenuse, which means cosecant is going to be the reciprocal of that, hypotenuse over opposite. And then you have secant. Secant is hypotenuse over adjacent. Remember, adjacent is the side that touches your angle in question. So hypotenuse over adjacent is the reciprocal of cosine. And then cotangent is adjacent over opposite. So again, the reciprocal of tangent. Well, remember, tangent is sine over cosine. So that means cotangent is going to be cosine over sine. Okay. So let's see what this actually looks like. So if this is what we're talking about here, so you're going to have an angle in question. Now you only have two places these angle in questions can be. It's either going to be down here or down here. You will never ever have an angle in question at the right angle. So keep that in mind as you're going through this. So your angle in question will either be A or B, either one. And then depending on where your angle is at that we're focusing on, that's how you determine things. So if this is my angle in question here, opposite is going to be the side that does not touch the actual angle. So since it's the side that does not touch the actual angle, the side and the angle actually will go together. And so since they go together, angle A will actually be with side A. So then your, oops, wrong button. So then your angle B, are your same one here. Let's go back. I'm pressing random buttons here again. So if this is my angle in question here, then adjacent is going to be the side that actually touches your angle in question. So since adjacent is a side that actually touches your angle in question, it's not going to be the same side as the angle. It's going to be the side that's next to it. So it's going to be side B. And again, over the hypotenuse. All right. Hypotenuse is always the one that's going to be across from the right angle. So when we're actually looking at these and actually doing these, you just need to remember the location. So remember, when you're talking about opposite, the side and the angle letter are going to match. So if this is angle B, that means we're going to be looking at side B for opposite. And that means the other leg of the triangle that we're looking at will be the other side. So if this is my angle in question, adjacent is going to be the other leg. Okay. It will always touch your angle in question. And then hypotenuse will stay the same through all of them. Hypotenuse is always across your right angle. All right. So evaluating trig functions. So we're going to find the values of the 6 trig functions in this figure below. And so with that being said, this is my angle in question. The reason I know that's because that's where theta is at. So before we begin, we have to make sure we have values for all 3 sides. And notice we only have the values for 2 sides here. So that means I have a right triangle. So again, thinking back to geometry, when you did this, then you have to wind up looking at the Pythagorean theorem to be able to find the other side. So if that's the case in a right triangle, you have a squared plus b squared equals c squared. So your Pythagorean theorem is a squared plus b squared is equal to c squared. They gave me b and they gave me a. So I have 3 squared plus 4 squared. That's going to equal c squared. So we have 9 plus 16 is equal to c squared. So 25 is equal to c squared, which means that my c is going to be equal to 5. Normally, when you take a square root of something, you have a plus or a minus. But in this case, because I'm dealing with an actual length, I only want the positive answer. So in this case, my c is going to equal 5. So now, I have that. So what I want to look at now is I want to find the values of the 6 trig functions. So I'm going to start off with my ones that you did back in geometry, which is sine. And then we have cosine. And then we have tangent. So we're going to start off with those. So sine is opposite over hypotenuse. So my angle in question here at theta is going to be opposite over hypotenuse. And so my answer will be 3 over 5. Okay. Oops, let's try that again. So cosine. Cosine is going to be adjacent over hypotenuse. So I have adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. So it's going to be opposite over adjacent. And if you're ever not sure on tangent, remember tangent, and you'll learn this later, but I'm going to say it again, is sine over cosine. And so when you're looking at the actual numbers here, you're just going to take the numerators of the sine and the cosine, and that's how you wind up with that right there. For the other ones that we have now learned, which is going to be cosecant, so CSC, secant, which is SEC, and cotangent, which is COT. Remember, these are reciprocal, so you're going to take whatever you found here and you're just going to flip them. So cosecant is 5 over 3, secant is 5 over 4, and cotangent is 4 over 3. Because again, these over here, the blue over here is reciprocals of the main 3. All right. So with that being said, let's talk about the 2 special right triangles that you hopefully should, again, remember back from geometry. So you'll notice I'm going to be talking a lot about geometry here because that is where you first get your real full dose of actual right triangle trig. So we're going to start off with the 45, 45, 90 triangle. And if you remember, the reason it's called 45, 45, 90 is because both angles are 45 degrees. So a right triangle with 45 degrees, or pi over 4, so make sure you're starting to remember those. The angle is isosceles. That basically means that because we have 2 angles that are exactly the same, the triangles are going to, not the triangles, the sides are going to be exactly the same. So that means if that's the case, I have 2 angles that are the same. That means its 2 legs are going to be the same. And so when you use the Pythagorean theorem, that's why you get a square root of 2. Okay, so you have a specific relationship here with these. And so when you're dealing with right triangle trig, you have the 45, 45, 90 and the 30, 60, 90 triangles that have these formulas. So for both sine and cosine, your relationship is going to be the same either way because you have that isosceles triangle happening here, which is 1 over the square root of 2. Now, you cannot keep that as 1 over the square root of 2 because you are not allowed to have a square root in the denominator. So since you can't have a square root in the denominator, you have to rationalize your denominator, which basically means multiply top and bottom by the square root of 2. So sine and cosine are really square root of 2 over 2. Okay. For your tangent, so your tangent, again, is your opposite over hypotenuse. I'm sorry, I lied. Your opposite over your adjacent. So if you take a look at that, opposite over adjacent, 1 over 1, which basically means that tangent is just going to be equal to 1. So because tangent is equal to 1, cotangent is also going to be equal to 1. So both sine and cosine and tangent and cotangent are going to be exactly the same, which means that your cosecant, try that again. Your cosecant and your secant will also be exactly the same, which is going to be the reciprocal of that right there, which is simply going to be square root of 2. Because remember, it's hypotenuse over either opposite or adjacent, depending on which one of those you're doing. So when you have a 45, 45, 90, you only have to remember these 3 numbers right here, because these 3 numbers are going to wind up being your relationships. Okay. The other one is going to be your 30, 60, 90. So your 30, 60, 90, again, is coming off an equilateral triangle. So that's why this piece over here is drawn like that. And so because that piece is drawn over here, we're basically taking an equilateral triangle and we're going to cut this in half. And again, so your 30 degrees is pi over 6. Your 60 degrees is pi over 3. So those, again, are two things that you need to remember. So now, when we're talking about what are those relationships, if I've got sine of 60 degrees, my sine of 60 degrees is opposite over hypotenuse. So that is the square root of 3 over 2, which means my cosecant of 60 degrees is 2 square roots of 3 over 3, because remember, you cannot have a square root in the denominator. For cosine of 60 degrees, your cosine of 60 degrees is adjacent over hypotenuse, which is 1/2, which means that your secant of 60 degrees is simply going to be 2. And then you have your tangent of 60 degrees, which is opposite over adjacent. So it's going to be the square root of 3, which means that your cotangent is going to be the reciprocal of that. Remember, you cannot have a radical in the denominator, so it's going to wind up being root 3 over 3. Okay? Now, here's the cool thing about this. You need to remember these numbers. So when we talk about 30 degrees, they're going to be the same numbers, except they're just going to be in a different order. Okay? So you're not going to get any new numbers. You're just going to get a different order that they're going to be going in. So let's see here. So remember those numbers. So then if I've got sine of 30 degrees, that's going to give me 1 over 2, which means my cosecant of 30 degrees will be 2. Cosine of 30 degrees is going to wind up being square root of 3 over 2, which means my secant, I do that all the time, my secant of 30 degrees will wind up being 2 square roots of 3 over 3. And then my tangent of 30 degrees is going to be square root of 3 over 3, which means my cotangent of 30 degrees is going to be the square root of 3. Okay? So you'll notice that the tangent from the 30 to the 60, they just switch places, going back and forth this way. And then the sine of 30 degrees is the same thing as the cosine of 60 degrees. And the cosine of 60 degrees is the same thing as sine of 30 degrees. So these two, pretty much, they just switch places in terms of their ratios. So make sure you have those written down somewhere. That's something that we're going to come back to later on, but you'll need to know those relationships, the 60 degrees and the 30 degrees, as well as the 45 degrees. Okay? So now, we did this one already. So we're going to use this figure to evaluate cosecant, secant, and cotangent, all of 45 degrees. Oops. So cosecant of 45 degrees. So remember, cosecant is the reciprocal of sine. So reciprocal of sine, well, so sine is opposite over hypotenuse, so its reciprocal is hypotenuse over opposite. So this is simply going to be the square root of 2. Secant is going to be the same thing. So secant, because again, it's a 45, 45, 90. So cosecant and secant are going to be the same thing. And then cotangent is opposite over, no, it's not. It's adjacent over opposite. Well, adjacent over its opposite is 1 over 1, which is simply 1. Okay. Use the figure to find tangent of 60 and tangent of 30. And so you're going to see this a lot. You have to rationalize your denominator. You're not allowed to keep a square root in the denominator. So tangent of 60 degrees is opposite over adjacent, which is the square root of 3 over 1, which is simply the square root of 3. And then tangent of 30 degrees. So it's opposite again over adjacent. So it's 1 over the square root of 3, which is just simply the square root of 3 over 3. Okay. All right. So here's a nice little chart. If you did not have the opportunity to write those down, go ahead and write those down. I'll give you a few moments for that. Because this is something that you're going to have to put into memory. So the 30, the 45, and the 60, these are all going to play a big, huge part because you should recognize those numbers from the first quadrant of your unit circle. So go ahead and pause the video if you do not have this written down, and go ahead and write this down so that way you'll have a nice place to keep this. And pause it now. All right. So hopefully that worked for you. So I'm going to show you a trick. If you notice with your 30, 45, and 60 for sine and cosine, everything is going to be over 2. I'm going to go back. So if you notice everything here, including this, because this is really 2 over 2, but we're only talking about sine and cosine, so I'm not really worried about tangent. But if you look at your sine and cosine here, everything is over 2. And then if you notice, it's 1, 2, 3. So if you take a look at this, when you do this, you'll be able to look at these and be able to figure this out. So if I'm looking at cosine here, we are going to start off with cosine. And we're going to start off with 3, 2, and 1. Remember, the square root of 1 is just 1. That's 1/2. Which means that if you remember what we were talking about earlier, the cosine of 60 is the same as sine is 30. So sine is 1, 2, and 3, which again, this is just 1/2. So if you can remember that pattern, that's going to help you a whole heck of a lot going forward. All right. So now, let's talk about introduction to identities. So a big portion of trigonometry is dealing with identities. So you're going to have some basic ones, and then you're going to get more complex, because eventually what's going to happen is you're going to verify identities, and you have a whole bunch of properties that you're actually going to do and look at and use to be able to verify these identities. So before we move on, in case you forgot, we need to talk about fractions, because part of this will be dealing with fractions, and you're going to have to be able to reduce these down pretty good too. So if you don't remember how to divide fractions, this is just an algorithm that shows you how to actually do this. And so what you're doing with this is, if this is your problem, you're going to copy and then dot and then flip. So you're going to copy the numerator. Then you're going to take this division sign that's right here, and that becomes a dot. And then you take the denominator and you're going to flip that. So that's where the copy dot flip comes from. And then when you do that, you wind up with this, because then you just multiply straight across. If you want to cross cancel, you can. If you don't want to deal with that and you want to deal with it later, you can do that too. Either way is correct. All right. So, given the triangles here, we want to evaluate the expression here. So, part of your work is going to be, they're going to give you these two triangles and then they're going to tell you something to actually be able to do. In this case, they want to know what is tangent of 45 minus sine of 60. So we know that tangent of 45 degrees, so tangent is just going to be a 1. And then sine of 60 is opposite over hypotenuse. So minus the square root of 2, I lied, minus the square root of 3 over 2. So when I clean this up, I need to get a common denominator here. So I have 2 minus 2, or 2 over 2 minus root 3 over 2. So when I combine all this together as one big fraction, I get that. And then I just combine my numerators because I cannot combine the 2 and the root 3 together. And so therefore my answer is going to be B. So when you get into these type of problems, just, pay attention to what you're doing and everything. And so, and then follow along with your fractions and then get that one common denominator and boom, you're done. All right. All right. Well, let's talk about identities. So we've talked about these already. I told you that sine and cosecant, they're reciprocals. So this is just verifying and showing you that these are your reciprocals of each other. So sine is 1 over cosecant, which means cosecant's 1 over sine. That's how they relate to each other. And then you have your quotient identities. Well, quotient only happens with tangent and cotangent. So keep that in mind. Quotient only happens with tangent and cotangent. So if you haven't got a chance to write these down, hit the pause button and go ahead and write these down. Make sure they have these titles here. All right, and pause it. All right, hopefully you have those in your notes. So here we go. Using the quotient and reciprocal identities. So given sine of theta is 2 over 3 and cosine is square root of 5 over 3, find the values of each of their 4 remaining trig functions. So we are going to find the values of these. Oop, press the wrong one. So, using these right here, the ones that we just talked about, we're going to put everything together. So I need to figure out, they gave me sine and cosine, so I need to figure out tangent, cotangent. Remember, all this is of theta, that's the angle in question. Cosecant, which is the reciprocal of sine, and secant, which is the reciprocal of cosine. So we're going to do these two first because those are the easier ones. So cosecant is a reciprocal of sine, so just take that 2/3 and now it becomes 3/2. Secant is a reciprocal of cosine, so that's 3 over the square root of 5, which is the same thing as 3 square roots of 5 over 5. Tangent is sine over cosine. So this is where the refraction review comes into play. So we have sine all over cosine. So as I'm looking at this, I'm going to say, okay, so sine over cosine. So I have 2 over 3 times 3 over square root of 5. Those will cancel, and this leaves me with 2 over the square root of 5. So I know that I can't have that square root on the bottom, so I have to rationalize. So I get 2 square roots of 5 over 5. Cotangent is the reciprocal of tangent, so this is a square root of 5 all over 2. So that's how you use your reciprocal identities and your quotient identities to be able to figure out the other two given the information that they gave you here. All right. Pythagorean identities. So This one right here, sine squared plus cosine squared equals 1. This is your main Pythagorean identity. And this is the biggest one because this is the one that actually creates these two over here. So if you're taking a look at this, if I take my original Pythagorean identity here and I divide everything by cosine, I wind up with this one. So this one is dividing the original Pythagorean theorem by cosine squared. That gives me this one right here. To get this one over here, I take the original identity and divide everything by sine squared. So these two over here are an off play of this one. And these are going to be important later on because when I'm dealing with secant squared, sometimes I don't want secant squared. I need to force a tangent in there, and this forces that tangent to happen. So, given that sine of theta is 1/2 and theta is an acute angle, find the value of cosine using the trig identity. So, given that sine theta is 1/2, and I need to figure out what sine is. So, I'm going to use this one here. So, I've got sine squared plus cosine squared is equal to 1. I know that my sine of theta is going to be 1/2. That's going to be squared. Plus cosine squared is equal to 1. So then I get 1/4 plus cosine squared is equal to 1. So I have cosine squared is equal to 3/4. I'm going to square root both sides like that. And when I do that, I wind up with cosine of theta is equal to the square root of 3/2. So this is just telling you this is my sine of theta. So I want to come over here and say, okay, if this is my sine of theta, I'm going to use this. So this is something else that you need to remember. This sine squared theta is the same thing as sine of theta squared. The same thing with cosine, tangent, all that. This is how it's really written. I don't know why they do it this way. They just do, but they mean the same thing. That's why I was able to plug in that 1/2 right there like that. So now we're going to talk about complements and cofunctions. So you know in a right triangle, 90 degrees is already used up right there, which means I have 90 degrees left over for these two angles. So if one of them's theta, the other one has to be 90 minus theta. So if I'm looking at their complements, I'm looking at theta here and then 90 minus theta. So this is 15. This is 90 minus 15 or 75. So that's what a cofunction is. So you have specific cofunction identities, just to let you know. Sine of theta is the same thing as cosine of 90 minus theta. Tangent is not as cotangent of 90 minus theta, and so on. So as you're going through here, if they're trying to find cofunctions, you know, just what we talked about earlier when we're doing that one thing. If I have the sine of 30, that's going to be the same thing as the cosine of 60. So that's all this is saying, that these two are going to have the same exact value. So the sine of 30 is 1/2. The cosine of 60 will also be 1/2. Okay? So all I want to do is find the cofunction here. I know that sine, so that on the sine, so sine of theta is the same thing as cosine of 90 minus theta. So if my sine is 46 degrees, its cofunction is going to be cosine of 90 minus 46. So cosine of 44 degrees. for cotangent. So cotangent of theta is the same thing as tangent of pi over 2 minus theta. So that means my cotangent of pi over 12 is going to be tangent of pi over 2 minus pi over 12. So that means that this is really tangent of 6 pi over 12 minus pi over 12, which gives me tangent of 5 pi over 12. All right, evaluating trig functions. So when you're evaluating trig functions, here is the key, this piece that's highlighted right here in your calculator. Be sure to set the mode to degrees or radians depending on the function you are evaluating. So pay attention to what the question is asking. If it gives you sine of 47 degrees, then you're going to be in degree mode. But if it gives you sine of 3 pi over 4, you need to be in radian mode. So you have to pay attention to that. So if I'm looking at this, I need to go to, on the first one, sine of 72.8. Make sure you have your calculator set in degree mode in order to do this one. So I'm going to come over here and I'm going to go to mode, and notice that when I come down here, I'm in radian. I need to arrow over to degree. So then I'm going to go sine of 72.8 and I get 0.955. So it's usually 4 decimal places is what it wants. So 0.9553. So my answer is 0.9553. Cosecant of 1.5. So this is 1.5. There's no degree symbol here, so this is radian. You need to remember that cosecant is the same thing as sine, or 1 over sine. So this is what you're going to put in your calculator for that one. So we need to go back to mode, go over to radian this time, make sure it switches over to radian. And we're going to go 1, let's try that again. Here it is. We have 1 over sine of 1.5. And 3 decimal places, so I get 1.003. So 1.003. So just pay attention. The hardest piece is to make sure that you're actually going back and forth between radians and degrees. So let's talk about angles of elevations and depression. So when we are going to go into applications of trig and stuff, you're going to have to understand if I'm looking for an angle of elevation or an angle of depression. And so what that means is basically your line of sight. So if you're standing here, this is your line of sight. If I look straight across, that's horizontal. If I'm looking at a plane, I'm looking up, so that's an angle of elevation. If I'm looking down at this car over here, that's going to be an angle of depression. And so notice how the triangles are going to be formed. That's going to be a big thing. So please make sure you pay attention to what you're actually doing in your word problems. So if you're standing on the ground looking at the top of a tree, if you're standing on the ground looking at a plane or a kite or whatever else, you have an angle of elevation. If you're standing up here looking down a water slide or looking on the top of a building, somebody walking away or whatever, you have an angle of depression. So those are the way the triangles need to be drawn. So, and sometimes you may not have to worry about it. So we have an irregular blue shape and the figure represents a lake. The distance across the lake A is unknown. So we're looking at that. We don't know what that is. But to find this distance, a surveyor took the measurement shown in the figure. What's the distance across the lake? So when you're doing these, you need to draw the picture. I cannot stress this enough. Please draw the picture. If nothing else, draw the triangle, because you have to be able to see the relationship. My angle in question to the two sides. What is the angle in question to the two sides? I will tell you this. You will only use 3, sine, cosine, or tangent. You won't have to worry about the other 3, but just sine, cosine, or tangent. So if I'm looking at this, if I'm standing here and I'm looking straight across, that's going to be opposite, and I have an adjacent, so that's tangent. So a tangent of 24 degrees is opposite over adjacent. And now I'm going to solve this for that A. I'm going to multiply both sides by the 750 yards. So times tangent of 24 degrees is equal to A. So now you have to go to a calculator. When you're dealing with these triangles, pay attention to what they're giving to you. So, and this one's going to be in degree mode because that's what they gave me the angle in. And I'm literally going to type in what I have here. 750 tangent of 24. Boom, 300. Did it say what I need to? Let's go 1 decimal place. So 333.9. So my A is 333.9 yards. So please, 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 please make sure you draw the triangle and label it correctly. Without that, you're not going to be able to see that this is a tangent relationship. Okay. Hypotenuse, that's usually when you're looking at the hypotenuse, the length of the kite that's being flown. How far are you from the plane that's flying above? Things like that. Distance down here, obviously that should be self-explanatory. So you have to be able to draw these. If you can't draw these, and you're not going to be able to figure out, is this going to be sine, cosine, or tangent? Because it's only going to be one of them. It's not going to be all 3. So when you go through these, please make sure you are using this, okay? You're using your triangles and stuff. All right. That takes care of right triangle trig. If you need more word problems to work on, let me know. I can always send those to you. But in your homework, I think you have quite a few of those you can actually be able to do. Make sure you draw the triangles. For all of these, make sure you draw the triangles. You know they're going to be right triangles because the section is called right triangle trig. Okay? So please make sure you are doing that. With that being said, if you have no further questions, which you can't ask me anyway because this is a recording, I guess I will talk to you when I talk to you. Y'all have a good day now. TTFN. Ta-ta for now.